We are going to talk about exporting metadata. So we covered on this topic a little bit last time. So where we have asterisk.tables within the module and schema path, these are all the table JSON metadata with some SQL as well. We're not going to go into the SQL. You can poke on that on your own. We will look at ivr.json. It's just an example. So we have columns, we have foreign keys, we have primary keys, which, as mentioned, we don't check yet. So that's part of the project, just to add checking. We have primary keys. So one of the items that we need to check is check for sequences. So let's take a look at that one. Check to make sure sequences exist. So this is going to involve exporting a new type of data. So this, as you can see, is based on tables. So we have a table, ivr.json. As we know, Postgres sequences are not specifically tied to a table. They exist at the schema level. So we would most likely be creating a new file at the schema level. And we could make, let's call it, this is old style, like asterisk.fks, JSON, aggregates, SQL. That's kind of old stuff. We're going to be, let's say, we'll make a new file, and it's going to be asterisk dot, because that's the name of the schema, and that's going to be dot db dot JSON. So that's going to be our JSON file for general database type things. And we're going to export something that looks like this. We're going to want sequences. We're going to want anything else that's schema specific and not related to a table. So what's in our checklist here? So enums are related to only a schema. I call it. Been debating on like plural versus singular. We've been kind of migrating towards more singular type of stuff, so we'll call it sequence enum. Rule. No, not rule. Rules are rules are on a relation. Casts are schema specific. They actually might be database specific. Let's not get into casters yet. Check constraints, enums, rules, cast language, aggregates. Yeah, and we'll do aggregates, aggregate, no comma there. And what else? Triggers we do handle in another way right now. So we'll worry about these three things. So this is our example. So sequences, we're going to want to export same style. We're going to want to export same style as everything else. It's going to be a hash of sequence names. And we're going to want to export increment, and that's probably good for now. So increment is going to be whatever. Don't need a comma. Enums. So enums are going to be a list of enums. So we're going to have, let's say, you know, my type, and it's going to have a list of types. So it's going to say, you know, if you have an enum type of, let's say, you know, 1, 2, and we're going to check to make sure our enums have these values. Aggregates, we'll get into aggregates later. I think this should give us a good start for sequences and enums. So since we're going to actually be exporting to this file, I'm going to overwrite it when we export. So I'm going to make a backup of this. I'll call it template. So we want our export to look like this. So how do we do that? The script that we're going to use to generate that file here is going to be apps dev bin get table metadata. So this probably will get renamed in the future because it's going to be doing more than just table metadata. It's going to be doing sequences and things that aren't specifically table related. But that's fine. We can keep the name. And so we have some functions, table detail, constraint detail, function calls that get these various tidbits. So we're going to want to now generate that file that we just talked about, which is the schema name .db.json in the modules module name db/schema name directory. So we generate that using a path that was given on the command line. We'll get into that in a little bit. But basically, schema equals the path. So we'll just write an example. This is we already know the module that was given to us in this variable. So we have a concatenation of the schema name. So really, we're this is this part of the path. So then we're tacking on the name of the schema, and then the schema name dot tables. That's the path that's we're going to be exporting the individual table JSON, but we need to make a new one. So we're going to make schema meta path is going to be the exact same base path, and we're going to append schema, and we're going to do schema.db.json. I always like to put examples, and that's going to be *db.json. So this is going to define schema specific stuff that's not table related. Just the thought process that went into this. I figured just doing this on the video would be useful. So we know where we're going to write. So we know we're going to do a write file using file slurp, which this script already uses. And I believe it's file name and then the data. So we're going to have our schema meta JSON. So we're going to do a JSON to JSON. We have some options, standard options that we pass for to JSON. I think they're in this file. Yes, they are. We use pretty, which makes nice new lines and things like that. So it's nice to look at it in diffs. We use canonical, which is important because then we have a stable export. When we look at the diffs in Git, they're not resorted in any which way because we know hashes are unordered lists. So after we generate our data, so that's the cleanup of the old stuff, we always do a fresh export, delete out all the old .sql and all the old .jsons prior to re-export, and we're going to do, this is generic schema metadata. And then what we're going to do is we're going to get some information on our sequences. So we're going to define a new hash, and then we're going to set our sequences. So we're going to open up IntelliSoft system lib any perl Postgres info get all sequence data, I think it is, sequence detail actually. So we need to do a Postgres info ::. This is our, we'll just call it sequence detail. And we're going to pass it our DB handle because it takes opsdb. Not all these things are well documented, but they pretty much all work the same. They take a DB handle, which is our PBXDB, and a schema name, which is here, my schema. So the schema is going to be the schema that was given to us in the script, which we already have. Sequence detail. And then now we have So we need to, as mentioned, we need to export the asterisk.db JSON data. We need to create this file and populate the sequences in here. So this is how we're going to do that. So we're going to just literally dump our sequence detail, which might not be in the right format. So how do we get sequence detail back from Postgres info? So that's a really good question. It's going to be, looks like we just return the result directly, which is fine. So we have an array. Anything that comes back from the database from a select is going to be an array, unless we do like a special option like single value, or which we don't need. So sequence detail, we need to process this and make a hash. So we're going to do my we'll just sequence item in my sequence detail, and then we're going to write out to our sequence meta JSON. We're going to write out to sequence with our sequence name. So what's the name of our NSP name is the schema. Rel name is the name of the relations. Schema sequences are actually relations internally in Postgres. So it's going to be the rel name is the name of our sequence, equals the sequence item. So we're gonna store all of this data in the metadata JSON. So I think that's all we need. So we're gonna get sequence detail, which is gonna be an array, and we pass it the schema, and then for each one of our items, we're gonna build a hash indexed by rel name, and we're gonna write out to the sequence file, or the JSON file with our sequence data. So a good way to execute this is actually not specifically running get table metadata, but get all table metadata in core, which will loop through all the different schemas and do this for every single schema in the module, which it died. So, oh, this is from the example that I did earlier, so I'm going to pause and fix this. And we're back. And I fixed this was from an example I made, didn't change the variable name, so that's all good. We have an issue, our actual issue is, oh, check tables redefined. Okay, I might have more things to fix, hang on. Okay, I fixed the rest of the issues in the upgrade utils PM. So, no DB handle, so what did we do wrong? We have no DB handle at get all sequence detail. So DB arrow PBX DB. Do we? Oh, it's sorry, it's $DB, not PBX DB. Okay, DB is a simple DB4, and yeah, so that should work a bit better. Select start value. Alrighty, so I'm gonna check this out. So the issue is this query, which doesn't seem like it's friendly with our current version of Postgres. It looks like start value doesn't exist in the metadata. So I'm actually going to disable this. We don't need the current value of the sequence, we just need the name. So we need to add a slash. So it's doing a schema name. Yeah, we need a slash in between. Which I should have noticed that earlier. There you go. And we should be in much better shape. Great. So no more errors. So these are all different schemas in the core module, and we should now have a JSON file with sequence rel name. We missed an item. It should have been the actual value rel name, not the name rel name. Yeah, so it's going to be our sequence item rel name. Sorry about that. Re-export. And now we have, oh, wrong file. We have db.json, which is all the sequences. We don't have the increment, so we'll get into that later. But here's just a really good example of now we have the metadata that we need to use in order to now check sequences. So the function helper in upgrade utils for check tables. So the check table for each, we're gonna, from a design perspective, we're gonna need a brand new sub. So check schemas, check schema for each. So we'll need a check schema for each, which can borrow a lot of the same logic to do. So implement this. So yeah, we could borrow this mostly the same logic from the check table for each, except don't go into traversing tables. So we just want module and schema. So we could start by doing that. I'll just leave this here for good measure. And this is already populated for you, so you don't have to worry about that. So we have the module, we have the schema, and we're going to run per schema callback, just like we have it registered in here. So we're going to use the same parameters. We're going to get our DB handle, any options for each callback. So we're just going to run that, right? This is our callback. So now in the check schema for each, we're going to have to load the example, right, is asterisk slash asterisk dot db dot json. So it's going to be module, and it's going to be schema, and it's going to be schema. So if we load this for every single module, for every single schema, we're going to have sequences now. And then we could do a check sequences and give our DB handle. So hopefully this makes sense. We're going to have a new pattern for doing per schema checking.